Hello and welcome to another video. In this video we're going to be working on make the string great. And in this problem you're given a string of upper and lowercase letters. And you can't have letters next to each other that are the same if one is uppercase and one is lowercase. So two lowercase is fine and two uppercase is fine, but you can't have like a lowercase e and an uppercase e. And you're allowed to delete these letters. You're allowed to delete two letters right next to each other that one is upper and one is lower. So either you can delete something like this. They have to be the same as well, or you can delete something like this. So either one's fine. And you can delete whatever way you want as long as the two letters are the same letter and they're different casings. And then you return the string that's the output, and the answer is guaranteed to be unique. So because they tell you that it's unique, if you actually look at this example, it doesn't matter which way you delete. Like if we delete like this will give us this, or if we delete the other way, it will also give us the same thing. So that's the key to this problem. Like it doesn't really matter where you delete, which way you delete. So if we have this, it doesn't matter. We can delete either this way or this way, and it'll give you the same thing. So essentially, we can have a strategy of just we keep getting letters, and whenever we get two letters that are, deletable, then we delete. But you can also have this case, so the letters won't always be right next to each other. So for example, if we have A, B, B, A, C, C. So after one deletion, we can delete this. But notice now that now if we delete those, then the A and the A are next to each other, and we can delete those too. But they weren't next to each other to begin with. So you need some kind of data structure that will allow that. And the best thing for that is a stack. So we can walk through this example and then talk about how to do all this stuff. So let's say we have a stack of where we just put characters on. So we put on an A for this example, then we put on a B, then we put on a B, and here we have okay. So actually, before we put on a character, let's say we have this A and B. So we can put on the A in the beginning because it's an empty stack. Then whenever we put on a new character, we check, is it uppercase or lowercase? So this is lowercase. So if this other character was uppercase, then we can just delete from the stack instead of putting this B on. So what that would look like is, let's say we put on this A, then we put on the B because it's different from the A. Then when we're about to put on this B, we check, is the last character in the stack a lowercase b because it's uppercase? And if it is, instead of putting this on, we just delete the last character from the stack. And then we can put on an A, but before putting it on, we check, is the last character in the stack a lowercase a because this is uppercase? Yes, it is. So instead of putting this on, we delete. Then we have two C's, so we put on a C, and then before this one, same thing. This is uppercase, so this needs to be lowercase c to delete. Otherwise, we put this on. This is, and then we just have an empty stack, and finally we join up our stack to make a string. And so I wanted to briefly talk about some methods you can make, depending on what language you have. How would you do something like convert to lowercase, or check, or convert to uppercase, or check if a string is lower or uppercase, or all these things. They're built into a lot of languages, but I wanted to talk about how you could write them for yourself. So if you're not familiar, characters are actually stored as numbers under the hood. So if you take a look, this lowercase a is stored as a 97, and then this z is stored as a 122. So it's called an ASCII table. So essentially every character is stored as a number, and then we can get this number value from the character depending on the language. Like in Python, if you call ORD on the character, it will give you this number. And in Java, you can actually just convert it to an integer and it will give you the number. So you can see that lowercase a to z means you just get the number from this character, and if it's between 97 and 122, then that's a lowercase character. So it's easy to check that, right? You just go through the character, you check, is that value 97 through 122? That means it's lower. Same thing for upper. If it's 65 through 90, it's upper. So we can check if it's lower or upper based on that, and we can also convert from lower and upper really easily. So the way to do that is you just take a look at the difference between the same character in lower and upper. So you see a uppercase A. So uppercase characters actually have a smaller value in ASCII. So uppercase A is a 65. Lowercase a is a 97. So convert from upper to lower, you would have to add 32. And then to convert from lower to upper, you would subtract 32. And that works for every character. So for example, if we have a lowercase s, if we subtract 32 here, we'll get 83. And then that's the uppercase s. So that's how you convert from lower and upper. You just add or subtract 32. And to check if it's lower or upper, you just check, is that ASCII value in the range? And you can check if the character is a number or alphanumeric or any of these things just by looking where are the ASCII values of these things, and that's where I can check. And then you just have a couple if statements. So if to check if a character is numeric, for example, you can check, is the ASCII value between 48 and 57 and so on. So that's how you can write all these functions. If you had to write them yourself, like is alphanumeric to lower to upper, all these things. And from knowing that, so now we can code it. So the first thing we're going to do is we're actually going to make a function that will take two characters and compare if, like, what we need to do is we need to detect if one of them is lowercase and one of them is uppercase. So for example, if we have something like this should return true. If it's like this, it should return true. And they have to also be the same character. So like this should be false, this should be false, and so on. But when we get two characters that one is lower and one is upper, it should return true. And for things like this should be false. And for things like this, it should be false. They have to be one lower, one upper, and they have to be the same. So that's what we can code first. And then we can use that to determine if we need to delete or we can add to the stack. So we can make a Boolean function called character compare. And there's probably a bunch of stuff like built into Java, but I just wanted to show how to make like all these generic things that you can use in any language if you needed to. So we're going to take two characters. And we're going to use this ASCII stuff to do this. So first we're going to check if X is in uppercase. So if we actually look, uppercase is, we can like make it more modular or we can make an uppercase function, but I'm just going to write it all into one. So uppercase is between 65 and 90. So we're going to use that. So we're going to say if X is between 65 and 90, and Y has to be lower, right? If X is upper, then Y has to be lower. So for lower, it's 97 and 120. No, yeah, 122. So, yeah. So Y has to be between 97 and 122. And they have to be the same character. So how do we check if they're the same character? Well, since Y is the lowercase character, we can just take the character that Y is. So let's say it's like this. And remember the difference was 32. So we can take, let's get the value for the Y character, subtract 32, and that should be X. So if we subtract 32 here, we will get 80, which is uppercase P. So that's what we're going to do in the code. So we can say Y minus 32 equals X. So in Java, you can actually you can compare characters directly like this. And when you do this, this will give you an integer, and you can compare an integer to a character, and the way it will compare is it'll just get that ASCII value for the character. So we can do this. In another language, you might have to do like ORD or whatever language you're in, but just get the ASCII value for Y, subtract 32, and that should equal the ASCII value for X. So if this is true, return true. And so this is where X is upper and Y is lower. And now we basically want the reverse of that. If X is lower and Y is upper, so this is going to be all very similar. We just swap the X and the Y. So this is just swapped. So now Y will be the upper character. So Y, this should be Y, I think. Let's see. Actually, no, this should be X, right? Swapped. Yeah, so this is the upper character. This is the lower character. And now this should be X minus 32 equals Y. So that's the case of Y being the upper character and X is the lower character, but they're still the same character. So if either one of these is true, then our characters are the same. Just one is upper and one's lower, and they should be deleted. Otherwise, we can return false. And now we can use this function to go through our string and do the rest of it. So also in Java, like in most things, you can use a stack. In Java, you can use a string builder, and that's literally what it's for. So it's kind of like a stack. Where you just keep adding characters to it. I think under the hood it probably uses some kind of like list or something. Like you can probably use like a character list as well. So we can use a string builder. And yeah, it has like push and pop operations and so on. So we're going to loop through the string. And so the first thing we need to do is, remember, to add a character, our string can't be empty. So we're going to check, is our string empty first? So if, so if the result is not empty, and so we need to compare the last character in our string that we're currently building. And also this string builder, we are adding characters, but we're not like building a new string each time. So this one wouldn't be like O of n squared. It's like using a stack. Like you're just adding a character at a time. So push and pop should be O of 1. Okay, And so now we have to do this character compare of the last character in our string builder to the character we're currently adding. So character compare result character at, and you have to give it an index here. So I think there probably is like result last character or something if I look it up, but we'll just use this instead. So this is just going to be result length -1. And then the character we want to compare it to is going to be the character we're currently inserting, which is this one. So if these, if this is true, that means the characters are, like, one of these characters is lowercase and one is uppercase, so we just want to pop. So if this is true, we want to just pop, so we'll say, like I said, there's probably delete last character or something, I just don't know it off the top of my hand, or top of my head. So we can do this operation instead, which will just delete the last character, you just delete at the last index. Otherwise, we want to append. And then finally, at the end, on the string builder, there's a method that will convert it to a string. So it'll just take the actual string builder that we built, and it will just get a string. So we can do that with this. Okay, there we go. And that should work, hopefully. And yeah, like I said, for Java, what I would recommend, especially if you're kind of like newer to Java, because Java's like a billion methods, you can code these things in like IntelliJ or use autocomplete, so you can see all the methods in here, because there's just like a billion methods in all these things that are good to know. So yeah, so this does work. And let's go through the time and space. There is like a 2-pointer solution, but you are overriding the input, which is usually not preferred, so I'm not going to go into that one. So here the time is O of n, because essentially with a stack, worst case scenario, you're pushing and popping once to the stack, which is fine. And you're also not comparing too much as well. Like, worst case scenario, you're comparing two characters next to each other like once, so it's not that bad either. So this will be O of n space, because we do have that string builder. And yeah, it's going to be all for this one. Hopefully this whole ASCII thing is useful to you. You can do a lot with it. You can write all these like built-in functions yourself in a lot of languages. I know I think languages like Go don't have all these like string methods. You just have to write everything yourself. So just wanted to show you how to do that. But yeah, it's going to be all for this one. Hopefully you liked it. And if you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.